Preparing for what comes next is a big part of becoming an adult. So, if your teenager says they want to join the military, they're preparing for a real challenge. Visit todaysmilitary.com because their success tomorrow begins with your support today.
Experiences are what people love the most about travel. That's why they love Viator. They have over 300,000 bookable experiences and something for everyone. Plus, their travel experiences have millions of real traveler reviews, so you have the information you need to book the best activities for your trip. Download the Viator app now and use code Viator10 for 10% off your first booking in the app. One app, over 300,000 travel experiences you'll remember. Do more with Viator.
Hi there, thanks for joining us on the latest edition of Space Nuts. I'm Andrew Dunkley, your host. Great to have your company. Coming up today, we're going to look at volcanoes, not on Earth, not on Mars, but on Venus, and it's starting to look like some of them might actually be active. Wow, that's quite a thing. And we've spoken before about the Ryugu asteroid. Samples of that were brought back to Earth, and they've done some more analysis on them, and some more revelations have been made. We'll also be answering questions about visible light energy, how slow can light go, and matter and antimatter questions as well. That's all coming up on this edition of Space Nuts.
15 seconds. Guidance is internal. 10, 9, ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
And joining me to discuss all of that at length, and we'll be finished in a couple of minutes, is Professor Fred Watson, astronomer at large.
Thank you. What a great show that was.
Yes,
Thanks, Andrew.
Yes. Catch you next week. How are you, Fred?
I'm very well, thank you. I'm coming to you from a hotel room in Canberra, which is where the lighting, if people are watching on YouTube, the lighting is less than optimal. But you can probably see that it's me. The reason why I'm sort of sitting here without headphones or anything like that is because my plans have changed. I was supposed to be going back home to Sydney yesterday after meetings at the Department of Industry and at Questacon, the science centre here in Canberra. But I got my days wrong. I've just had a lightning flash there, so I'm just going to take myself off the mains just in case there's a power surge through the mains. It shouldn't have any effect because I've got a full charge on the battery on the laptop. I'll unplug the phone as well.
Better.
So I in fact, I got my days wrong. So all this is my fault. But today, at the National Press Club, which is one of the main ways that what you might call government, in fact, it is often government. Politicians use this a lot. It's sometimes other people who are in public life for one reason or another. It's the the voice that allows people to communicate their ideas and policies sometimes. So the National Press Club is a big gig. The National Press Club lunch is a very big deal. And today, at the National Press Club, we have the NASA administrator, Bill Nelson.
Wow.
And his deputy, Pam Melroy, who we know because she wrote a lovely endorsement of Cosmic Chronicles when it came out. And I've done the gig with her in the past and things like that. So it seemed like a good idea to try and get myself into that.
Yes.
My colleagues in the Department of Industry and the Space Agency, actually, I think it's the Space Agency that I'm going with, have found me a ticket. So I shall be there at 11:30 this morning, assuming we don't all get washed away by the rain that I think is now falling outside.
Yeah, but that's exciting. What a great event. Of course, the National Press Club is always broadcast on the ABC. So people can tune in and watch that at lunchtime, our time. But it's quite often the way that politicians get grilled, and it's
that's right.
Yeah, it gets more attention leading up to a federal election, but it operates very regularly and always a source of news stories and information. So that'll be great. That'll be really exciting. Wish I was
Maybe I'll
there.
be able to report on it next week or whenever.
Perhaps.
It is interesting, as you said. They politicians use it for election policies. We are 3 days out or 2 days out now from a state election.
Yep.
Right here. But I guess that doesn't count in the National Press Club because the Australian Capital Territory, where the press club is not New South Wales.
No, it's not. And to be honest, I really don't know which way the election's going to go this weekend. You could, it could go either way. I guess it just depends on the mood of the electorate in the wake of COVID-19. But the sitting party is coming out of some turmoil with a few changes in the ranks forced upon them by unfortunate situation. So it'll be interesting to see where it goes. I'm just not sure. Okay, let's get down to business, Fred. And volcanoes on Venus, we know they exist. We know they're on Earth. We know they're on many planets, Titan, etc., and moons. But these ones are starting to look like they're just not sitting there dormant, twiddling their thumbs. There's signs of activity. That's pretty interesting.
It is. Yeah, I think this is a really exciting result. So at present, we know for certain of two volcanically active bodies in the solar system. One is our own planet, and the other, of course, is Io, Jupiter's little moon that's quite near to Jupiter. Actually, it's quite a big moon when you compare some of the other moons of Jupiter, which are just rocks. But Io's stretched and squeezed by the gravitational attraction of Jupiter, the tidal forces, and so is very volcanically active. In fact, it's considered to be the most volcanically active.
Did I say Titan? I thought Titan was, but it's Io.
Yes, that's right. Titan, actually, you're not wrong, because there's evidence of cryovolcanoes on Titan.
I knew there was something.
These are things that emit freezing cold slush. That's right. So you're not off the mark. But Io's certainly the most volcanic one. But Venus, kind of since the Magellan spacecraft, which was in orbit around Venus 30 years ago, since because Venus has got this huge atmosphere, thick clouds. It's not a huge atmosphere; it's just a normal atmosphere, but it's very thick, high density, 100 times the pressure of our atmosphere here on Earth, and essentially opaque, so that you can't see the surface directly. Magellan, to combat that, was equipped with the very accurate radar system. So, this sort of radar that allows you to map the terrain beneath and give you topographical information like hill heights, mountain heights, and all the rest of it. And so that's why we've got really good maps of Venus's surface. And my recollection from the statistics is that what we know about that is that Venus has the most volcanoes of any object in the solar system.
Wow.
We've believed until now it was volcanically dormant. That these come from an ancient period when Venus was much more geologically active than it is today. Until now.
Yeah.
What's happened, Andrew, is it's actually a scientist at the University of Alaska, Robert Herrick, who's a planetary scientist, and he's published a paper which has come out this week at the 54th Lunar Planetary Science Conference in Houston. And what he's detected is a particular volcanic vent that's changed its shape. And the reason why he can do that is that when Magellan was flying over Venus and doing its mapping, it actually did, certainly for some parts of Venus, it did 3 cycles between 1991 and 1992, and something like 42% of the planet was imaged or radar imaged more than once, at least twice. So that's what allowed this scientist to trawl through the data and look at differences between the two sets of images. I think they're about 8 months apart, if I remember rightly from the paper. Yes, Professor Herrick has realized that one particular crater, and it's actually one of the biggest, it's a mountain called Mart, M-A-A-T, Mons. Mons is just Mount. And it's very close to Venus's equator. The essence of his argument was that if you were going to look for activity today, you would look at the biggest volcanoes, and you might also think about looking on the equator, which is, where you experience, tidal forces and centrifugal forces and all of that stuff.
Yep.
Not that probably makes much difference, but you're looking. And he's got this lovely comment about his search through the data. It was a search for a needle in a haystack without any guarantee that there was a needle there. He said, if you're going to bet on where the most likely place for an eruption to occur on Venus, this would be it. It's the tallest volcano on the planet. And sure enough, he's realized that there's an area which is the sort of summit. It's the crater summit of Mart Mons, which is about nearly 2.5 kilometers wide,
and about 8 kilometers in height. That mountain, isn't it?
Yes, incredible. That's right,
big mountain.
But that area had doubled in size over the 8 months.
Wow.
And what he's suggesting is maybe there's, let me quote Professor Herrick. The most reasonable interpretation of that data is that there has been an eruption that has come up and changed the shape of the vent and filled it so it looks like a lava lake that has filled up to near the rim. And in fact, he's goes on to say, on Earth, there's never been, as far as I know, a volcanic event that is changed by multiple kilometers without an eruption occurring somewhere nearby.
Yeah.
And I think that's probably fair enough. And what he's suggesting, that there is another aspect to this, because apparently there's an area in the radar images that's near the vent, in fact downstream from the vent, that's brighter in the later images. And that suggests a rougher surface. Bright usually means rough when you're looking at radar images. And Professor Herrick says this suggests that perhaps a new flow of lava has formed. But he said there was a caveat with that because they can't actually rule out the possibility that particular observation was an artifact of the viewing angle, which is different between the two. But that's been ruled out for the main observation.
Okay. It's quite extraordinary. Are we, if this is the case, and it seems pretty obvious that it is, with volcanic activity on Venus, what's causing the volcanic activity? Is it tectonics? Because they don't have tectonics on Mars. We do on Earth, and that's got a lot to do with what is happening beneath the surface and moving all that magma around. What's the story on Venus?
So I think you and I, probably a year or so ago, Andrew, had a story that was, again, from Magellan data, and it was looking at sort of linear features on the surface of Mars. And this is different. It wasn't recording any changes or anything, but it was suggesting that the particular layout of these features could be due to low-level tectonic activity, that you were getting perhaps some sort of division into crustal plates. Now, as we get to know, did I say Mars there when I meant Venus? I can't remember. Anyway, I'm not talking about Mars. I'm talking about Venus. So these crustal plates may actually be moving, and I guess all of this is going to be food for thought. For the Veritas mission, which you and I have talked about, which is a NASA mission. There's also an ESA mission called Envision, which I think both of those will have much more detailed radar capabilities. Apparently they're not scheduled for launch until the the early 2030s.
Was that thunder I just heard?
Yes.
Wow.
Yes, it's quite loud outside. So we've got the whole thing today.
Yeah,
We've
yeah.
got the wrong place, the wrong time, and a thunderstorm. It couldn't get any better.
Wow. So it's, that Veritas mission, unfortunately, has been pushed back and probably won't be launched until 2028 at the earliest, but probably 2031 is the year they're looking at now. So we're going to have to be very patient to get the backup data. But, gee, and the other pity about Venus is we can't see a damn thing. We just, wouldn't it be great if we could actually do what we do on Mars and have an orbital spacecraft that can take high-resolution photos? But all we get is cloud.
Yes. Well, that's right. The clouds themselves are really interesting, though, with their sulfuric acid aerosols and things like that.
Yeah.
But you're right. I just put in a plug for a former colleague of mine who's sadly no longer with us, David Allen. He used the Anglo-Australian telescope at Coonabarabran in New South Wales, the one I used to be astronomer in charge of, back in probably the early 1990s, maybe 1980s, late 1980s. But he actually used an infrared camera on that telescope to demonstrate that he could detect the surface of Venus in infrared radiation. But I think it was more of a glimpse than anything, just a region of the clouds where the transparency was a bit higher than it is elsewhere. But it got an infrared signal that could only have been the surface because of its temperature.
Okay. All right. Well, we'll watch with interest, and we will hopefully learn more about the volcanic activity of Venus in the not too distant future. This is Space Nuts with Andrew Dunkley and Professor Fred Watson. Let's take a short break from the show to talk about our sponsor, NordVPN. Now, I've told you about NordVPN many times. I use them myself. In fact, I use everything that they offer at the moment. I did a bit of an upgrade the other day and very, very happy indeed. I love its smart thinking because I don't have to worry about remembering passwords. And if I go to a website that has a username and password that I haven't used for a while and I can't remember it, it automatically is ready to give me the information. So it's really fantastic that way. And it works on my Windows machine. It works on my iPhone. It works on my iPad. I don't have to think about it. It is the world's leading virtual private network by reputation and has been backed by many, many big corporations that you know very well. They use advanced security and privacy features that protect you from online threats, and they've announced the launch of their latest version of NordVPN, which is in the form of an app for Windows, which I'm experienced with now. You can even integrate it with your Windows computer so that when you log onto the computer, you don't have to sign into Nord. You can get Windows to do it for you. So they integrate really, really well. There are quick connect buttons in the system, and Nord is committed to user privacy and security. It's very much evident in their strict no-log policies. And they don't collect and store your data either, if you're worried about that. So have a go, check it out, because it's trusted by millions of users around the world, including me. And it's a robust system, and they've got servers in over 60 countries. And I've tested the speed with my NordVPN, and I am getting lightning speeds on my devices. I pay for a 50/20 plan on my home computer, and the other day through Nord, I got 52 megabits per second download, which, it's above what I was paying for. So pretty impressive stuff. Now, if you'd like to take advantage of the offer that's available to Space Nuts listeners, it's really simple. Just go to nordvpn.com/spacenuts. That's nordvpn.com/spacenuts. Click on the button, get the deal. You won't be disappointed. Now, back to the show.
0G, and I feel fine.
Space Nuts.
Okay, Fred, let's move on from volcanoes on Venus to asteroids that have very interesting things that we're learning, including the one that had a return sample brought back to Earth that's been analysed, and that is Ryugu. And I did see a lot of these news stories popping up this morning because they've made another pretty startling discovery in this regard too.
That's right. I've got the Nature Communications paper in front of me now. It is titled Uracil in the Carbonaceous Asteroid 162173 Ryugu. And there's a very long list of authors.
Yeah.
Most of whom, as you might expect, are Japanese names. Because it's not all of them, but most of them, because it's a Japanese spacecraft that brought back that sample. Maybe I might just read the abstract of that paper, at least some of it, because it's not gobbledygook like so many of these so many of these research paper abstracts are. It starts off: the pristine sample from near-Earth carbonaceous asteroid 162173 Ryugu, collected by the Hayabusa 2 spacecraft, enabled us to analyze the pristine extraterrestrial material without uncontrolled exposure to the Earth's atmosphere and biosphere. And of course, that's what you get with meteorites, Andrew. They lie on the surface of the Earth.
Yeah.
And so you can't rule out contamination. And so the abstract goes on to say the initial analysis team for the soluble organic matter reported the detection of a wide variety of organic molecules, including racemic amino acids in the Ryugu sample. Here we report the detection of uracil, one of the 4 nucleobases in ribonucleic acid. That's RNA.
Yeah.
In aqueous extract from Ryugu samples. And it goes on to look at the details. And the suggestion is that what we've got here is a component of RNA. Now, RNA is not DNA, but it's one of the molecules, the sort of enabling molecules that's very important in living organisms on Earth. So this amino acid is a bit of a tracer. Once again, that these complex organic molecules were able to form probably in the depths of space in cold molecular clouds and then condense onto primitive asteroids like Ryugu. That's one reason why this asteroid was chosen for the mission, because it's a carbonaceous asteroid. It's probably one of the earliest types of object formed as the solar system was forming. And it's got this uracil in. Now, I'm not an organic chemist by any means, but I think it's a pretty exciting result. Just a caveat again there, I believe that uracil has also been detected in meteorite samples.
Yeah.
But as I was just saying, because meteorites land on the ground and sometimes lie there for quite a long time, you can't rule out.
I believe it's also found in the uracil bunny.
The one that keeps on going.
Sorry, that was just so awful. I had to do it.
Oh, gosh. Yeah, the dad jokes are thick and fast.
Yeah, we did a whole bunch of them on the radio the other day, and I haven't stopped hearing about it because it was the answer to my quiz question, the origin of dad jokes.
Oh, right. Okay.
Yeah, they date way back to 1987.
Who was the original dad, though?
That's the thing, yeah. They were defined in 1987. I'm sure they existed a lot further back than that.
Yeah. Yeah. But what a great, coming back from Duracell to Uracil. A great result. Very, very interesting. There's if our listeners and watchers want to catch up a little bit on it, there is a really interesting article on The Conversation by Trevor Ireland, who's professor of at the School of Earth and Environmental Scientists in the University of Queensland. And so his article really captures the excitement of that and gives all the details for anybody who's interested in organic chemistry. And it also has a link to the original paper as well.
I suppose the question that comes up with a discovery like this and the previous discoveries as a consequence of analysis of the samples from Ryugu is, what does it mean for planets like ours that have advanced life? Is this like, would you call Ryugu like a seed pod or something like that? And asteroids like it have perhaps been responsible for creating the opportunity for life to exist on this and perhaps other planets?
Yep, I think that's a really good analogy. Quite extraordinary. Actually, there's a little postscript here which I meant to mention, and it's Trevor Ireland's paper that's reminded me of it. So amino acids, which, if I understand things correctly, go towards proteins. Those amino acids that are produced by life processes on Earth, there's a thing, let me just step back. There's a thing called chirality. Do you know about this? I can't remember whether I've ever talked about this before, but I've always thought it was really interesting.
Knowing my memory, we probably have, but it's not coming through.
It's about the way complex molecules are put together, and many of these, certainly amino acids, can be put together in either a left-handed way or a right-handed way. It's just the structure of the molecules.
Okay.
If you think about your left hand and your right hand, they're symmetric, and some of these molecules are. So you can put them together either one way, and it's called left-handed, or right-handed. That is the chirality. Chirality is whether it's left or right-handed. And all amino acids produced by life processes on Earth are left-handed.
Wow.
However, the ones that come from the Ryugu samples are equally both right-handed and left-handed molecules. And so what Trevor Ireland draws from this, and I think it's probably the view of experts in this field, it indicates the molecules found on Ryugu are not signs of life because they've got this equal distribution of left and right-handed. If you found they were all left-handed, like life is on Earth, maybe you'd start thinking a bit more deeply about it.
Yeah, so you're telling me I was wrong, actually, but anyway.
No, I'm not. No, because the seed pods they're not seed pods of life. They're seed pods of the building blocks of life. That way.
So it's a case of hits the Earth, just add water.
Yeah, that's right. And a few other complex molecules.
A few other things too, just to chuck into the mix.
Yeah.
I think the creator reminds me of my childhood. I'd get a jar and I'd just put stuff in it to see what happens. Nearly blew myself up one day because I added honey to powdered chlorine.
Oh my! Wow!
And it turned into a blasted bomb. I picked it up and the jar was really hot, almost burning hot.
Yes.
And I didn't know what I was doing at the time. I was an idiot, but I guess that's how these things happen, and that's possibly how life evolved on this planet, just some kind of weird mix that was just right.
Yes, accidental reaction. People have talked about this in detail, and that's certainly part of the story. But another part that I've always found interesting is you need sort of fatty molecules as well, lipids, because what you want is to have these fatty molecules that can provide a kind of envelope, in other words, a cell wall within which these reactions can take place, so that you actually confine them. They're not just reactions taking place in an amorphous blob of something. You've got them confined within a cell, and that's the way people think maybe cells originated.
Speaking of which, I saw an article last week that suggested that by 2050, more than 50% of the world's population will be obese. I know that's got nothing to do with Ryugu, but you were talking about fatty molecules and just popped into my head. That's quite a staggering statistic when you think about it.
It is, yes.
And they've released a report on the data and suggested that the world needs to do something about it, and that's probably true. But can we expect more revelations from Ryugu going forward?
I think we probably can. I think we should watch this space. There's, I don't think they're going to find DNA in it or anything like that.
Wouldn't that be a
really
shock?
Interesting. That would be a shock, yes.
Quite extraordinary. All right, more to come on Ryugu, but as Fred said, if you want to chase that story up, it's on the conversation.com website.
Como padre, maestro o mentor, tiene la oportunidad de ayudar a un joven a construir un futuro. Si lo que desea es unirse a las Fuerzas Armadas, tómese el tiempo para informarse en todaysmilitary.com. Su éxito del mañana empieza con su apoyo hoy.
Hello, Saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
3, 2, 1.
Space nuts.
Oh, gosh, we're travelling along at a rate of knots, Fred, but it is question time. We've got 3 questions to deal with today, 2 audio questions and a text question. We will firstly hear from Rennie, who is asking us about visible light energy.
Hi, this is Rennie Traub from West Hills, California. Thank you for answering my last question. I have another one that's been bothering me. The question has to do with the visible light coming out of the sun. If at all possible, in simple terms, what creates these light particles, and how do these particles have enough energy to travel across the universe to an observer's eye? And why can't we mimic this energy to propel our rockets that would carry our robotic space explorers?
Wow, that's a lot. That's a big question. So I suppose in a couple of parts, what creates the light particles initially?
And it's a fantastic question, which has a pretty neat answer, Andrew.
The sun.
Well, the sun, yeah. So deep in the sun's core, and this is way below, the levels that we can see. Let's look at what we can see of the sun. What we see is something called the photosphere, which is essentially the kind of boundary of the sun below which you can't see.
Yeah.
Now, the sun's a ball of gas, but the photosphere is the almost what you might call the light-emitting surface. It's where the radiation actually escapes from this ball of gas.
Mm.
But that radiation has had a long and tumultuous journey, because deep in the sun's interior, that's the core. It's where the nuclear reactions are taking place that power the sun. And as you know, the main reaction is turning hydrogen into helium. And that process actually gives you a slight mass loss. If I remember rightly, the sun loses, is it 6 million tons per second of mass? It's something like that. It's
Sounds like a lot.
It is, yes. And when you multiply that by c squared, the speed of light squared, to get the energy loss, you can see that there's a huge amount of energy being created.
Yeah.
And that energy is in the form of electromagnetic radiation. In fact, it's gamma rays. It's high energy gamma rays that are created in the interior of the sun. But the density there is so high that a gamma ray photon emitted by a nuclear reaction doesn't get very far before it hits something else. And then it's scattered off. And that process repeatedly happens throughout the sun's interior. The photons are getting scattered from other nuclei, atomic nuclei, and eventually from other atoms. And that scattering reduces their energy. So as the sun, as the radiation gets finally to the surface of the sun, it's coming out as visible light. There are gamma rays as well, but they're at a much lower level. The predominant radiation is visible light. But this is the great thing, Andrew. That process, that scattering process, takes in the region of 200,000 years.
Yeah, it's incredible.
And it is. In fact, I think I wrote about it in one of the books. I can't remember which one. And I checked the best value. It's really a guess. People are. It's an estimate, not so much a guess. A guesstimate, perhaps, is the right word. Somewhere between 170,000 and 1 million years is what the figure is. So it's in the.
Does that actually mean the light hitting us now was created before the dawn of humanity?
Well, it means it's our distant ancestors' time. Yes,
Yeah.
That's right. It's not. I think we place kind of recognizable humans at about 2 million years ago.
Right.
Something like that.
That's pretty close.
And it may even be more than that. So it is pretty close. It's interesting, isn't it, that it takes maybe 200,000 or 300,000 years for light to get from the center of the sun to the edge, and then 8 minutes to get 150 million kilometers to us. So yes, it's a fascinating thing. So that's how the radiation kind of is created, Rene.
You wanted to know how does it travel so far once it gets out?
And that's because, light is, electromagnetic radiation doesn't have a limit to how far it will go. What limits it in reality is, the intensity eventually would get so low that it's undetectable by any means that we might have access to. But it goes on forever. Unlike the two fundamental forces which relate to atoms, which only have a very short range, the strong and weak nuclear forces. The two other fundamental forces, gravitation and electromagnetic radiation, effectively go on infinitely, but at very low levels, because it's an inverse square rule. It means that when it goes twice as far, its intensity drops by four times.
I have another theory, Rennie. If you're in jail for 200,000 years, you want to get as far away as you can when you get out.
Yeah, that's a good analogy there.
And how do we harness this power to, reach speeds that will get us traveling into the cosmos? I think was his last question.
It was how do we create artificial sunlight, I guess, to propel solar sails along, and that's exactly what the Breakthrough Starshot project's all about. It's trying to demonstrate the idea of using lasers to propel a solar sailed vehicle to Proxima Centauri, 4.2 light years away.
Yeah.
So people are thinking about it, Rene. It's a great question.
Fabulous. Thanks, Rennie. Hope we answered it adequately. Let's move on to our next question from Fenton.
Yeah, hello, Fred and Andrew. This is Fenton calling you from Minnesota in the U.S. I would mention off the top that I really like your show because you can hear questions from many different countries. I think that's really great. Anyway, here's my question. It's antimatter time. So, there is more matter than antimatter in the universe. How much more? What are the relative amounts of antimatter and matter? So, question number 2, is it conceivable that there's another solar system someplace that's made of antimatter? Question number 3, what would happen if we tried to shake hands with an antimatter person? Okay, thanks. I enjoy it. Hope you like the question. Bye-bye.
Love the question. Thank you, Fenton. There's more matter than antimatter, he suggests. How much more?
I'm sorry I can't remember the fractions, but it's overwhelmingly matter is the dominant, by very large quantities, the dominant type of matter in our part of the universe, not just the solar system, but probably our whole galaxy and maybe even our local group and the local cluster of galaxies. It's all matter. And by the way, just the reminder that antimatter is just like matter, but the subatomic particles have the opposite charge.
They're left-handed.
Yeah, they're left-handed, except it's a bit different. So let's just forget that.
You're all right.
That's molecules. So they've got the opposite electrical charge. So electrons have an antimatter equivalent called positrons, which have a positive electronic charge, positive charge to them. So we do know that antimatter is created in some nuclear reactions. And I read a story quite recently from one of the accelerators, and I can't remember whether it was the Large Hadron Collider or one of the accelerators in the United States, but they have an antimatter factory which produces tiny, tiny amounts of this stuff because you can't let it touch matter because the two annihilate with the production of a high energy photon. once again, gamma rays. And so that's actually one of the ways that people look for antimatter deep in the universe, because if you have matter and antimatter annihilating, you get a gamma ray with a particular spectrum signal. It's got a particular energy. And I'm not sure, whether there's evidence of cause of antimatter in some galaxies, for example, but that's the way that scientists look for it. So Fenton's question about whether there could be another solar system
made of antimatter
is not ruled out. We simply don't know. There may be other parts of the universe which have a bigger concentration of antimatter than matter. It may well be unlikely, because at one point the universe was all in one place. And I should just add that it's a puzzle, actually, as to why this is something that troubles cosmologists, why the universe, when it was created, why there was an imbalance, a slight imbalance between matter and antimatter. Because if there'd been a perfect match of matter and antimatter in the early universe, then the universe would have been completely made of energy. There wouldn't have been any matter at all, because it would all have annihilated if there was a perfect match of one to the other.
In that case, Fred, it wouldn't matter.
Oh. Ta-da! God, they're getting better as you go along.
I'm smouldering today. Certainly not on fire.
Well, just don't annihilate yourself with the.
Someone else will do that.
Yes. Yeah, they might. Anyway, yes, so there could be other regions of the universe that are made of antimatter, but we don't know.
Okay.
And if you shake hands with somebody, you're in big trouble. So if an antimatter person walks in your doorway there behind you, Andrew, keep well away. Keep well out of it.
Do not touch. Although they'd probably get destroyed by anything they touched, wouldn't they?
Well, the atmosphere would destroy them already.
So we're pretty safe.
Yeah.
Okay. Thank you, Fenton. And I hope you're well in Minnesota, and I hope it's getting warmer. One final question. This one comes from Emma in Brisbane. Hi, Fred and Andrew. I love your podcast. I have a question regarding the speed of light. Never had one of those before. What is the slowest light can travel through a medium? Could I go faster than light in that medium? How would I achieve this? Run fast. Would I then be able to say that I've gone faster than light? I wouldn't be able to say that I've gone faster than the maximum speed of light, but I would have gone faster than light at a speed. I need help finishing my bucket list. Thanks, Emma. What is the slowest that light can travel? And I did mention a week or two ago that there have been some experiments done, and they've actually managed to stop light dead in its tracks. So everybody has now achieved faster than light speed.
That's right.
Basically true.
Exactly right. So just to clarify, that it's the speed of light in a vacuum that's the ultimate speed limit, 300,000 kilometers per second. So that's the one you can never go faster. But as soon as light passes through glass or water or any transparent medium, it slows down by a significant amount. And that's why we have the phenomenon of refraction, because the light is changing its speed. But yes, you're absolutely right, Andrew. Modern physics, some modern physics experiments with laser light and really quite interesting media that they're passing the light through. I think what you're doing is trying to trap photons among subatomic particles. I'm not directly across that, but I do recall that there is, the record has been dropping over the last few years, that light has been traveling at a few centimeters per second rather than a few 100,000 kilometers per second. And eventually somebody's managed to create a stationary photon. Yes, everybody has traveled faster than the speed of light. So you can cross that off your bucket list, Emma.
Yeah, all done.
Great to hear from you.
Yeah, you just
to go and love in Brisbane.
Yes, indeed. Yeah, lovely city. I love Brisbane. Hate their football team, but love Brisbane. Actually, they've got two football teams now, because we've got a new one started this year. It's they've won their first 3 games, as it turns out, the Dolphins. So they're off to a flying start. Thank you, Rennie. Thank you, Fenton. Thank you, Emma. And that brings us to the end of our show this week. And don't forget to visit our website, because that's where you can send us questions. Click on the AMA tab where you can send us text or audio questions, or just click on the send us your voice message on the right-hand side. And don't forget to tell us who you are, where you're from, and how many dogs you own and what they eat for breakfast. We want to know everything. You can also visit the Astronomy Daily newsletter on our website. The Space Nuts shop is there. And if you want to learn about how to support Space Nuts, whether it's to buy us a cup of coffee or to go the whole hog and become a patron, you can do that too. And thank you to our patrons who are such wonderful supporters of the podcast. We so much appreciate it. Fred, thank you so much. We're going to wrap it up and we'll catch you on the very next episode.
Sounds great, Andrew. All the best. And thanks again for a great show.
Stay dry and avoid politicians in Canberra at all costs. No, they're good people.
Yeah.
Thanks, Fred. Fred Watson, astronomer at large. And thanks to Hugh in the studio, who got us out live at the very last second this morning. I didn't give him more than a moment's notice. So well done, Hugh, for a change. And from me, Andrew Dunkley, thanks for your company. We look forward to your company again on the next episode of Space Nuts. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast. Available at Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com. This has been another quality podcast production from Bytes.com.